The SAT is going to have multiple problems that involve linear equations. So we're going to go over linear equations, review what they mean, how you find them, and then how you can relate them to word problems. So going back to the beginning here, we have linear equations. We have different forms. Okay, so first of all, when we say linear equations, see the word line, it's a line. So it goes like this or it goes like this. It could go horizontally and it can go up and down. But it's always a line. And being such, there's always going to be, there's usually going to be a y and an x, but both of them are going to be to the first power. So here's an example, one that a lot of people remember is the y equals mx plus b form. And what this is called is the slope-intercept form. There is another form, this form that we use a lot is a standard form, which is right here, but I'm going to just focus on the slope-intercept form right now. So when we look at this again, remember that the m stands for the slope of a line. And the slope, you can imagine, means how steep it is. And it also means whether it's going up as you go left to right or whether it's falling. Slope is really, keep this in mind, I'm going to say the slope is the rate of change. That's going to be important, the rate of change as something moves along. So here's some examples. You hear words such as something grows 5 inches per year. Okay, so it goes up 5 inches every 1 year in time. Or another one, something drains 2 gallons each hour. So each hour is like per year. It's as this starts, wherever this starts, it's going to lose 2 gallons. It's actually going to go down the amount. So it would actually be a minus 2 gallons every 1 hour. So slope is the rate of change, and it's right here, right before that x. Now notice, again, in these, the y has to be alone on one side. So what is the other part that's important is the b. The b is the end of this equation, and it stands for the y-intercept. So what does that mean? Well, it's sort of like where you quote-unquote start, even though a line really never begins or ends. But over here, when I was talking about this here with maybe something's draining and it started at, let's say a tank started at 20 gallons at 0 time. And then it starts draining. At 0, when the x-axis is 0, the starting amount in my example here was 20. So that would be the b. That would be the y-intercept. You might see something like a plant is 10 inches high when you buy it. So it would be at time 0, when you just get it, it's already 10 inches. Well, that 10 right there is b. That is your y-intercept. So let's just step back and recognize when we have linear equations, one of the most basic questions would be identify the slope and this should say y-intercept. Again, it's it's right here, y equals mx plus b. Whatever number is in front of x is the slope. Here it's the -5. And while I'm saying this, I want to bring up the word you're going to see so many times on the SAT, and that is called a constant. Familiarize yourself with that word. And constant means it's a number. It's a number. Now, we may not know it. We might. Constant would be different from a variable. A variable is going to be when you have your x's and your y's. How come? Well, if we have a line, and line looks something like this, and coordinates go along it, right? So this might be 2 for x and 4 for y. You have your x, y coordinates like that. But there may be another point on this line that is actually at 4, 7. So the x and the y's change depending on where you go. But for this little sketch line I have here, it goes up the same amount it goes over every time. The steepness is the same. The slope is the same throughout a line. It is constant. So a constant slope would be a constant. Y would be a variable, x is a variable, and b, the y-intercept, well, each line only has one place where it crosses this y-axis. So that is also a constant for a line. Okay? Those don't change unless you change the line. So looking at these equations here, just identify the slope and y-intercept. So in this one, the slope, we use m for slope. The slope is -5, and the b, or the y-intercept, is 6. Here the slope is 3, and the y-intercept is -2. Here the slope is -2. And I also want to point out, when we say the slope is, say, -5, that can also be thought of as it is -5 over 1. Okay, so slope is going to be how much it changes vertically, and I'll go into this in a second. But keep it in mind, the slope can be written with sort of as a fraction or a ratio. This right here, the slope is 3, but it's also could be called 3 over 1. So let's take a look at what this looks like on the graph. Here is a line, the equation y equals 1/2 x minus 2. Graph this in Desmos here. So in this equation, remember the y equals mx plus b form. The y is alone, so we can see the constant in front of the x is the slope. The slope is 1/2. And then the b is, the y-intercept is -2. All right, let's look at that means again. When the y-intercept is -2, okay, this is the y-axis here, right? And this is your x-axis going horizontally. The y-intercept is where this line crosses through. See, it hits the y-axis when y is -2. And the coordinate there is actually 0 for the x, -2 for the y. So the y-intercept is at 0, -2. And in our equation, that's why we see the -2. All right, so what does the slope mean? Let's take a look at the slope. So if you were to go, let's say you were giving directions to someone, and this is like, the person is here on a map, right here, and they need to get to this point right there. And you can't go diagonally. You can either go up, down, left, right. How do I get from here to here? Well, essentially what I do is I want to say, how much do I go up or down? I'm going to go up or down, and then how much over sideways. Now usually I'm talking about going as we go to the right. So here I want to go, if I go up one space, it's -2 to -1, and then I go horizontally 2 spaces, 1, 2, I've gone up 1, so it's 1 up, so it's a positive 1, and then at the same time I'm going right 2. So up 1 to the right 2. The slope is up 1, right 2, or 1/2. And you'll notice that happens again throughout the whole line. From here, I'll go up 1 space over 1, 2. That's our slope. So when we go to word problems, the SAT, they're going to ask you, what do these mean? They're more interested in, I think you're going to know the stuff we just went over, but they're going to say, okay, so how do you relate that to a word problem? And so they're specifically looking for, okay, what does the slope in your equation stand for in the real life problem, and what does the b or the y-intercept represent? Remember, keep in mind the slope is a rate of change. So let's take a look at an example here. Right here. So say you're paid to dog sit, and the family gives you $20 for each, see the word each, or per hour you're there, and always gives you a $15 tip for just showing up. So what do we got there? We've got $20 per hour. That is your slope. 20 up every 1 over. And yes, the 20 is in dollars, and the bottom number here, the change horizontally, is in hours. But we don't worry about the slope. We don't worry about the units. We just say up 20 every 1 to the right, right? So 20 over 1, or 20, is the slope. So far, if we're going to use the y equals mx plus b form, we're going to have y equals, and now we know the slope is 20, and we're going to put the letter x. All we need to know now is, what's the y-intercept? Well, remember, think of the y-intercept as sort of the start, especially in word problems. The start is when, here's the sort of the graph, and you start off with 15, right? Because you just show up even 0 hours. If you haven't even worked yet, they've already guaranteed you 15. So that's where the line's going to go through in our graph, because you start with 15. So you make, money you make is $20 times X is the number of hours, right, in this problem. And then you have the automatic 15. This will look like y equals 20x plus 15. Because the rate is 20 per hour and the 15 is the one-time tip. And that one-time tip doesn't change no matter how many hours you stay. Every trip, you get 15. So this would look like on a graph. So remember, we're doing $20 an hour. We get 15 to start. Our total pay equals 20 times hours. I put right here, $20 times hours worked plus the 15. So we could use those. Pay equals 20 hours plus 15. But in y equals mx plus b form, that's the same as writing here. And remember, $20 is constant. Every hour it's 20. And the 15 is constant every time you visit. It's just 15 to start with. Here's some examples. So try one of these, and then I'll go over it. So go ahead and read this one yourself and see what you think. Just pause the video and see if you can get the right answer. So don't be thrown off by it says G parentheses M, which is pronounced G of M. All right. For right now, just when they have this kind of stuff, it's notation. I go into a different video with functions. But what we've got here is essentially, this equation is really y is equal to, we have a negative 0.05 m plus 12.1. Now, this can be confusing because we really are used to the y equals mx plus b. What is this? But you see, they've given us, it's still in the same form of y equals mx plus b. Why do they have an m there? I mean, because m is our slope, right? Well, this is a real-life word problem. Whenever you're reading word problems like SAT, make sure you know what the different letters or variables stand for. So remember, it says that m is a number of miles. Okay, m is a number of miles, and g, the equation, the number of gallons that remains. Be careful, so how much is left. So when you look at this, ask yourself, picture it on a graph here. We've got two things going on. We've got a car using up gallons of gas, and then we've got, it starts with a certain amount, and then it loses a certain number of gallons. How much? It loses a certain amount per mile, right? That makes sense. It's burning up gas as you drive, or each mile, right? Per mile, each mile. That means that the miles is really down here. If you look at it on a graph, the number of miles driven, and this is going to be the gallons left, because it's going to burn it. So really, it's going to start off up here, full tank maybe, and the amount of gallons left is going to go down as you drive more miles. So you need to identify, they're trying to throw you off with this m, but identify that m miles is our x. This is our x-axis. And then on the left, when it's alone here, whether it's y equals or gm, it's the final amount. This is the amount we have left. And then keep in mind, like, so this right there, there's no variable attached. There's just 12.1. That's the starting amount to this. So we would start with 12.1 gallons, and then we're going to burn up 0.05 gallons each mile. All right? So it's really y is equal to, the amount left is equal to, we take away 0.05 gallons per each mile, okay, but I'm going to use x for miles. Plus, we start with our y-intercept is 12.1. That's the really equation in your what you're used to, the y equals mx plus b form. So how many gallons of gasoline are used to drive each mile? Well, you can see that every mile it's using up this much gas. But why? Here's that, but why is there no minus? Well, in the equation, the minus is telling us that we're losing gas. It's taken away. The question is asking how many are used. How many gallons of gas are used up? So it uses up 0.05 gallons every mile. So it uses, meaning it loses, meaning in the equation, yes, it's minus 0.5. But when they ask us how much is it using per mile, it's using 0.5 gallons. This one down here, try that. Pause the video and take a look at that and see how you do. Here we are again with this notation where it says f of x. And see, it's right here, f of x. Again, this is going to be function notation, but for right now, just when you see f of x, or up here we saw g of m, g of x, g of m, h of t, it doesn't equals, it's always on its own on the left. Just for now, just think of that as y equals. Now, I know people will say, well, why don't they just write y equals? Well, that's when we go into the function information, the function lessons on the SAT. But for right now, just consider this. I'm going to consider this equation y equals the 36x plus 1,000. All right? In context, we have to, well, I want to find my variables here. Okay? F is the cost to lease in 36 months. So it's going to be the total cost. The cost to lease is equal to, and now what is x? X is the monthly payment. So it's the monthly payment. And this is a little bit throwing you off here because often the x, you know, when we see the x-axis, often it's time. But in this case, the x is the monthly payment. So this is a little bit unusual. But let's keep that in mind. And then this is the total cost. Lease means rent. Okay, they're going to rent it. Well, let's look at what we know right away. We know that 36 is in front of the x. Okay, that means that it's in front of the x. That's the slope. Slope. Remember, slope can also be written 36 over 1. Okay, so that means whatever we start, we're going to go up 36 something every one we go over. That's the slope. All right, and then what is the x is the monthly payment. So this is monthly payment in dollars, how much you have to pay. And it wants what's the total cost to lease when the monthly, see how they say monthly payment is $400. And x is the monthly payment. So really you're just taking the 400 and plugging it into the x. All right, so the total cost will be 36. What is the 36? Well, the 36 was the number of months. 36 months times, they're saying, what if you get a payment plan of $400 per month? This is going to be your total cost that you pay for those 3 years. So then we would, in this case, you would plug in to solve. So we can solve this equation, but I also want to then take a look at other ways they could ask this question besides this one. So you're doing 36 times 400, and then you're going to add the 1,000, and that comes out to be this, right? So again, this is a little confusing because usually people see this is 36 months. That's kind of a time thing. We're so used to, a lot of times this would be days, this could be hours, this is often years. So the time is, when you have time, it's so often on the x-axis. This is a little bit confusing, so you got to be really careful that if we were to just see that this question wasn't too bad because you're plugging in 400, but if they were to ask what these things mean, you got to remember what the slope meant and then what the y-intercept means. The y-intercept means you have to put $1,000 down. Okay, so it's going to be $1,000 to start, and then you have to make 36 payments of the 400. But this is an example of how they're going to use linear equations and sneak them into these word problems. And as we see them, it's one thing to do y equals mx plus b over and over, but now seeing word problems is really what you need to get used to do well on the SAT. Now let's go on to how do we find the equation of a line. All right, so we can see a picture of it. You know, if you saw a picture of a graph and you saw, oh, it starts at 10 and then, oh, it goes down, let's say it goes down 2 every 1 you go over, right? If it was here and it goes down 2 spaces and then goes over 1 space, down to right 1, if you saw the graph, you could write it. You'd see the y-intercept. But what if we don't see a graph? All right, so then let's take a look at here. When we're given, there's two situations. One is where they give us the slope and they give us 1 point. Okay, so there's a couple ways you can do this, and I'm going to show you both ways, and then you can choose whichever one you want. I actually am going to start with number 2 because I think most people, it depends on where you're at with all this stuff. If this is pretty breeze for you, then you probably want to use this method, but let's just take a look at both methods and you can decide. So here's an example. We have a slope of 1/2 down here, and we have a coordinate, 6, -3. So the first thing I want to do, what I want to do is I want to label this. I want to tell myself, remind, okay, that the slope is 1/2, 1/2, and the coordinate, when I say it's 6, -3, go ahead and label that as x sub 1, y sub 1. Okay, so it's like, I know there's only 1 point, but get used to doing this where this is when I say x sub 1, y sub 1, that means a specific x and y coordinate. So I'm going to go under here, I'm going to go 6 is x1, and I'll do it here. x1 is equal to 6, and y1 is equal to -3. So what this does is point slope formula. It's actually a quick formula that you just plug in information. And I'm going to go ahead and do that. So notice the point slope formula is y. The formula is y take away y1 equals the slope, then parentheses, x take away x1. So in this situation right now, well, what do we got for? We're going to write the letter y. Keep that the letter y. But for y1, or y1 was down here, it was a -3. So I have to do, there's an automatic minus sign in there, so I've got to put y1, though, that is also a minus. That's a negative. So just write that for now. We'll simplify it after. The slope we said down here is 1/2. So put a 1/2. Parentheses, again, keep that letter x and then subtract the x1, which was 6, put that there. Now we're going to distribute in the 1/2 into both of these. So you're going to have 1/2 x, the minus sign's still there. 1/2 times 6 is 3. Simplify this, y take away -3, that's y plus 3, y plus 3. And if I want to get it into this y equals mx plus b form, all I need to do is subtract 3 from both sides. That gets rid of it there. We have now isolated y to, it's actually not -1/2, it's 1/2 x minus 6. All right, so that would be the equation of the line. But I want to go ahead and show you the other method for solving this, where I just, some people do this, and it's a little bit quicker if you know what you're doing. So this method right here, where you just, it says use y equals mx plus b and kind of fill in some information. So I would write the equation y equals mx plus b above. And so I already know the slope is 1/2. So I could write 1/2 under that. And in this case, you're just using a sample x and y, meaning I knew one of the coordinates was when x is 6 and y is -3. Okay, so when x is 6, okay, I'll put a 6 there. And y is -3, so I'm put a -3 there. We're looking for what b, or the y-intercept, would have to be to make this make sense. All right, so I just did y equals mx plus b, plugged in the x and y samples I have, plug in the slope. Now I have one variable left, one thing to solve for is the b. So we have negative 3 is equal to 1/2 times 6 is 3 plus b. Subtract 3 from both sides. You've got a negative 6 this is b. Negative 6 is equal to b. Now I have to go back and rewrite the equation y equals mx plus b, filling in, well, the slope again, and then putting in the y-intercept, which is the same answer we got before. So I'm going back to writing just the general y and general x. So some people find that faster. You're filling in and finding the b. Either one works. And now I want to go over something. What is the situation if you don't have the slope? Okay, you have 2 points or 2 coordinates on there. What do you do? Well, first I want to give you an example here. So we have this. I'll show you what to do. It's really similar to what we just did, but we have one step before that. Remember before we were given the slope? All right, when we knew the slope? We don't know the slope, so we need the slope. We're going to find the slope first, okay? And then this brings me to, what is the equation for slope? Right? Because we haven't done that yet. But to find the slope, when you have 2 coordinates, I'll just give you an example. Let's say we have, I'll give you an example down here. We have 1, negative 6, and then we have another point is negative 7, 2. First thing I want to do is I want to label these. I want to write this is x1, this is y1. So now it's going to make more sense why I use x1, y1. I'm going to call this the second x example that I have and the second y example. Right, so now I have 2 coordinates. Now the formula for slope, slope is m, equals, you do subtract, you go y2 minus y1, or the change in the y's, over x2 minus x1. So in our case right here, when we have x1 is, so I'm going to look at what I've got up here. So y1 is this 2. So I'm going to go 2, take away the the y2 is the 2. The y1 is, see the y1 is a negative 6. You got to put, because this isn't automatically a minus, but then the y1 is actually a minus 2. So we have that. x2 is the negative 7, take away automatically, and then the x1 is 1. 2 minus negative 6 is 8 over, this is negative 8. Of course, you want to simplify slopes. This goes to negative 1, because these both cancel. You can also write that as negative 1 over 1. All right, so now we have the slope. Now we have the slope is negative 1. What did we do here when we had the slope? Let's go ahead and use the point slope formula. All right. So the point slope formula again is y minus y1 equals mx minus x1. All right, so I write the letter y minus the y1, which was the negative 6, equals, see, we found the slope. Now we can use this formula. Just the letter x, take away x1, which is that. This turns out into y plus 6 over here. Distribute that negative 1 in, making sure you do it to both. Negative 1x, or negative x. Negative 1 times this minus 1 is a plus 1. Almost there. Subtract the 6 from both sides. You have y is equal to a negative x minus 5. See the slope there? The slope is, if you see negative x, remember that slope is a negative 1 over 1. Okay, so that would be the equation for that. And you could have done it this way. You could have just started with y equals mx plus b, and now we knew the slope was negative 1. One of our x values was, the x1 was 1. I'm going by this up here. And when y was negative 6, the x is 1. I have a slope of negative 1. Find out what the y-intercept must be. Negative 6 equals negative 1 plus b. When you add 1 both sides, you get negative 5 is equal to b. So we go ahead and rewrite our equation. Y is equal to, I write the slope, which was the negative 1 or negative x, and then I knew my b, negative 5. Got the same answer, whichever way you would like. Okay, so here's a quick example here. Let's say you're paid $16 an hour at Subway and expect $20 in tips every shift. All right. I also want to point up here too, this is like I did before, but sometimes you can do a table of values, meaning when you first were doing these, you do like when x is this, y is this. If you had an equation, sometimes it's in standard form, it was something like 2x plus 3y equals 6, you could kind of go, okay, when x is -2, what is y? Well, I'll go 2, put in a -2 for the x, plus 3y equals 6. This is a -4 plus 3y. If I add 4 to both sides, I get 3y is equal to 10, so when you divide both sides, you get y equals 10/3. Alright. If you put in 0 for x for this equation, you do 2 times 0 plus 3y is equal to 6. So this goes away. 3y equals 6, then y has to be 2. And so on, right? So you can make a table of values, and these are coordinates. You have -2 comma 10/3. Another coordinate would be the 0, 2, and you could plot those. Right, you could plot those on the graph. Okay, so again, we need to know what the slope is, the slope formula, and then often looking for b. So that's really a review of some of the important things you really need to know as basics going into the SAT as far as linear equations, how to find them, what they mean in word problems. And once you have that down, then you can go on to harder ones. But make sure you know all that. Bottom line, you got to know all that going into the SAT. So hopefully that helped you kind of review some, or if you've forgotten some, kind of making sure you're solid on that going into the test.